Hello everyone, thank you for signing in and watching my live stream. This is the SAT prep class, SAT ACT prep class. Today we're going to continue our conversation on the rules of exponents. I will be posting until I have the full live channel thing going on. I need 100 subscribers apparently to do that, so please like, favorite, and subscribe. Share my channel with all of your friends and family, whomever may be preparing for the SAT or ACT. But in the meantime, I'll link my my Facebook page in the description below, and I'll be posting the links for my live sessions there. I'll also be updating my YouTube page shortly. We're just editing all of the videos to include the guided lecture, independent practice problems, and learning partner activity videos that correspond to all of these subtopics that we're covering in all of my classes. Okay, so I hope you all are doing well. First of all, I wanted to just review some of the rules. I know that we went through in the last session kind of an exhaustive list here, but just to remind everybody of the rules of exponents. And let me share my screen with you. Okay, so remember, all the rules of exponents involve common bases. If you don't have common bases, then you can't use any of the rules of exponents. Exponents come in a form such as some base raised to a power. I'm going to call the base here a, and the exponent here m. So this guy right here, that's the base. This guy right there, that's the exponent. First rule, when you have common bases raised to exponents and you multiply the values together. So for example, a to the m times a to the n power. Now the a, m, and n just represent a certain number, right? So it could be any number. The a's have to be equal to each other, but when we have common bases raised to exponents and we multiply, we can keep the base, add the exponents. So for example, 3 cubed times 3 squared is 3 to the 3 plus 2 power, which would be 3 to the 5th. When we multiply, we can add the exponents. So when we divide, we can subtract. So a to the m power divided by a to the n can be simplified into the form a to the m minus n power. You just need to make sure that you keep the order straight. You need to make sure that you're subtracting the exponent of the denominator from the exponent of the numerator, because subtraction is not commutative. It's commutative. So order does matter with subtraction. So for example, sorry, let me do actual numbers here. 3 to the 5th power divided by 3 squared would be the same thing as 3 to the 5 minus 2 power, which is 3 cubed. And if you have any questions at any point, just let me know in the chat function. The third rule is a power of a power. So if I have a value that's already squared and I take that whole quantity in math, whenever we have a complex value, especially inside of parentheses, but it could be as part of the numerator, or making up the numerator, or making up a specific part of an equation, we can call that entire complex sequence of monomials or values in general as the quantity. So it makes things easier to describe. So here I could call this a to the m power quantity raised to the n power. When we have a power of a power, we can multiply. So for example, 3 cubed quantity raised to the 2nd power is the same thing as 3 to the 3 times 2 power, which would be 3 to the 6th. The fourth rule we talked about was involved negative exponents. So if we have a to the negative m power, we put everything under 1 and turn the exponent positive. So a to the negative m is equal to 1 over a to the positive m power. So for example, 3 to the negative 2 power is equal to 1 over 3 to the positive 2 power, which if we wanted to evaluate, we know would be, 1 over 9. Then we talked about fractional exponents. So if you have a number raised to a fractional exponent, the denominator of the exponent becomes the index value of the radical sign. The numerator of the exponent remains the exponent of the radicand. So the radicand is everything underneath of the radical sign. This whole thing, if I were to circle this whole thing, that would be called the radical. So just so you understand the vocab that we're using here, radicand is the number underneath of the radical sign. And also, this guy right here is called the index value of the radical. Just so you understand the terminology that's going on. So, for example, usually how we see this occur is when you're raising something to a fraction that has a numerator of 1, and that just completely translates into a rooting, some type of root. So for example, if we had 4 to the 1/2 power, the denominator becomes the index value of the radical. The numerator remains the exponent, but 4 to the first power is still just 4. The square root of 4 we could evaluate into 2. Same thing, like if we had 8 to the 1/3 power, that's simply another way, that's another way of writing the third root of something in a fractional exponential form. So this would be translated into the third root of 8 to the first power, but again, 8 to the first power is, any number to the first power is always going to be that number itself. So this is going to be just the cube root of 8, which is also 2. So if you have any questions on that, please let me know. The last rule involves solving an equation, and it's called dropping the bases. All of these other rules involved expanding or simplifying, however you wanted to think of it, you could do either. Simplifying expressions, but this rule is useful in its way that we can use it to solve equations, and we can represent it in kind of a conditional statement. If a to the m power is equal to a to the n power, then we must know, or then am must be equal to n. So if we have common bases on opposite sides of an equal sign, we can drop the bases and compare the exponents directly. So for example, this usually comes up when we have a variable as an exponent. So like 3 to the x power is equal to 3 to the, actually, you know what, I'm going to use a different base just to highlight a point here. Instead of 3, I'm going to put 9 to the, I'm going to say 9 to the 8th power. So notice we don't have common bases here, but one strategy we can always try to employ is rewriting in terms of a common base. Usually you can look at the smaller value, which is 3 here, and see if you can exponentiate that smaller value by some power that will equal the other value. And that is indeed what we can do here. 3 to the first power is 3, and 3 squared is 9. So the 3 to the x power is fine, but instead of writing 9, I could write 3 squared, and then I have a power over power. So then I'd have 3 to the x power is equal to 3 to the 2 times 8 power, which is 3 to the 16th power. Now I have common bases on opposite sides of an equal sign, so I can drop the bases and equate the exponents. So x has to be equal to 16. So I just wanted to lay down those fundamental rules. If you have any questions on those, please let me know. Otherwise, let's take a look at some questions. So I'm going to give you 2 minutes. Please look at these first 3 questions, and then I'll give you some hints, and then I'll give you the solutions. Okay, so for the first problem, what's the value of 6 to the third power times 6 to the negative 2 power? So we have common bases and we're multiplying, so we can add them. So this is going to simplify into 6 to the 3 plus negative 2. Notice that 3 plus negative 2 is the same thing as 3 minus 2, right? The second problem, we don't have common bases, so we need to see if we can exponentiate 10 in some power or to some power to equal 100, and you can definitely do that. 10 to the first power is 10. 10 squared is 100. So instead of 100, write 10 squared. We'd have 10 to the 6th divided by 10 squared, quantity squared. You still have that outside squared as well. Now you have a power of a power, so this would turn into 10 to the 6th power divided by 10 to the 4th power. So I'll leave you with that. Excuse me. The third question, what's the value of 7 to the 7th power quantity raised to the 4th power? So with a power of a power, we multiply. So this is the same thing as 7 to the 7 times 4 power. I'll give you one more minute, and then I'll give you the solutions. Okay, so for the first problem, 6 to the 3 plus negative 2 is going to be 6 to the first power, which is just 6. That's answer selection C. The second problem, we have 10 to the 6th power divided by 10 to the 4th power. That's the same thing as 10 to the 6 minus 4 power, which is 10 squared. That's answer selection A. And for the third problem, 7 to the 7 times 4 power is the same thing as 7 to the 28th power. And that's answer selection C. If you have any questions, please let me know. Otherwise, let's take a look at these three problems. I'll give you 2 minutes. Okay, so number 4 says, what is the value of 7 to the negative 2 power? So we know that that would be equivalent, an equivalent expression to 1 over 7 to the power, positive power of 2. So 1 over 7 squared, and you can evaluate that. 5, what's the value of 256 to the 1/4 power? So notice that's the same thing as the 4th root of 256 to the 1st power. Anything to the 1st power is that same something, so that's really just asking what is the 4th root of 256. What that really is asking, logically, is what number multiplied by itself four times is 256. So that's how you could logically go about simplifying that expression. For number 6, or 1.6, if 32 to the 4x plus 4 power is equal to 16 to the 6x plus 2 power, what is the value of x? So we don't have common bases here, so you need to rewrite these bases in terms of some other value. The problem, you might suspect that maybe because you have 16, 4 squared is 16, so maybe we could exponentiate by 4. But notice that 4 to the 1st power is 4. 4 squared is the same thing as 4 times 4, which is 16. So that's fine for 16, but notice that 4 cubed is the same thing as 4 times 4 times 4, which is actually 64. So between 4 squared and 4 cubed, we jump over 32. So it can't be 4, but notice that 4 is a power of another number. 4 is a power of 2. 2 to the 1st power is 2. 2 squared is 4, 2 to the third power is 8, 2 to the fourth power is 16, and 2 to the fifth power is 32. So instead of writing 32, you could write 2 to the fifth power, quantity raised to the 4x plus 4 is equal to, and instead of writing 16, you can write 2 to the fourth power is equal to, quantity raised to the 6x plus 2 power. Now make sure that you distribute. This 5 has to go to the 4x and to the 4. This 4 has to go to the 6x and the 2. Okay, I'll give you 2 more minutes, and then I'll give you the answers. Okay, so if we look at number 4, 1 over 7 squared, that's going to be equivalent to 1 over 49. 7 squared is 49, so the answer to 1.4 was B. 1.5, what's the value of 256 to the 1/4 power? So that's the same thing as the 4th root of 256, which is asking what number times itself 4 times is 256. That's going to be 4, because 4 to the 4th power is the same thing as 4 times 4 times 4 times 4. You can see from the previous problem that the 4 cubed is 64. 64 times 4 is 256. So the answer to 1.5 is going to be 4, which is answer selection C. And then for 6, we move this over here. So this is going to turn into 2 to the 5 times 4x plus 4 power, which is equal to 2 to the 4 times 6x plus 2 power. Make sure you distribute. So this is going to turn into 2 to the 20x plus 20 power is equal to 2 to the 24x plus 8 power. I'm just distributing that 5 to the 4x and then to the 4 on the left-hand side. And then I'm distributing that 4 on the outside of the parentheses to the 6x and to the 2. Now I have common bases on opposite sides of an equal sign, so I can drop the bases and just equate the exponents. So 20x plus 20 must be equal to 24x plus 8. So I'm going to subtract away 8 from the right. So if I subtract away 8 here and 8 here, 8's cancel here, and that leaves me with 20x plus 12 is equal to 24x. Now I'm going to subtract away 20x from the left and the right. If I do it to the left, I have to do it to the right. That cancels the 20x on the left-hand side of the equation and leaves me with just 12 is equal to 24x minus 20x would be 4x. Now I can divide by 4 on both sides, and x is going to be equal to 12 over 4, so x is going to be equal to 3. Oh, I'm sorry. My camera's in the way of that. I apologize. That's all of that problem. If you have any questions, please let me know in the live chat function. And if you're watching this recording, you can always comment below, and I check my comments. Very good. So let's move on to the next 3. I'll give you 2 minutes. Please look at these. Okay, let's look at these 3 problems. And sorry for that in mid-timing Zoom. I'll try and make the problem bigger so it's easier to read, though. 1.7, what's the value of 9 to the negative 2 power times 3 to the positive 6 power? So we don't have common bases. You have to have common bases to use any of these rules. Look at the smaller value. Ask yourself, so the smaller value is 3. Ask yourself, can I exponentiate that to a power to make it 9? Yes, because 3 to the first power is 3. 3 squared is 9. So instead of 9, you can write 3 squared. That's still raised to the negative 2 power, and then times 3 to the 6th power. Now you have a power of a power, so this is going to become 3 to the negative 4 power times 3 to the positive 6 power. For 1.8, we have, what is the value of 144 cubed divided by 12? So again, we don't have common bases, but look at that smaller base of 12. We can exponentiate that to a power of 2 to get 144. So instead of 144, I'm going to write 12 squared. Get a smaller pen here. So I'm going to write 12 squared. quantity cubed, because we still have that cube hanging outside the parentheses, divided by 12 to the first power, because 12, if it doesn't have an exponent, then the exponent is implicitly 1. So now you have a power over power, so this is going to become 12 to the 2 times 3 power, which is 12 to the 6 power, divided by 12 to the first power. And you can simplify from there. 1.9, what is the value of 2 to the 10th quantity raised to the 40th? So this is going to be the same thing as 2 to the 10 times 40th power. And I'll give you 1 more minute, and then I'll give you the answers. Okay, so for 1.7, we have 3 to the negative 4th times 3 to the positive 6. We have common bases raised to exponents, so we can add the bases. Keep the bases, add the exponents. So we have 3 to the negative 4 plus 6 power. That's going to turn into 3 squared. That's A. Excuse me. In 1.8, we have common bases down here. We have bases of 12 raised to exponents, and we're dividing, so we can keep the base of 12, subtract the exponents. It's going to be 6 minus 1, so this is going to turn into 12 to the 5th power. That's answer selection C. 1.9, we're multiplying here, so that's going to be 2 to the 400th power. Extremely large number. That's going to be answer selection D. If you have any questions, please let me know. Just one more set, and then we're going to get into some more, not that these aren't advanced, but we're going to get into some trickier exponent problems. So I'll give you 2 minutes. Please look at 1.10 through 1.12. Okay, so let's look at 1.10. What's the value of 3 to the negative fifth? So when we have a negative exponent, we just put everything under a positive 1 in a fraction, so 1 over 3 to the positive fifth power. And I'll leave you to evaluate that. This is going to convert into the fourth root of 625 to the first power, which to the first power doesn't have any effect, so it's just going to be the fourth root of 625. Notice what that's asking you. What number times itself 4 times is 625? And for 1.12, we don't have common bases here, but notice that 3 to the first power is 3, 3 squared is 9, 3 cubed is 27, and 3 to the fourth is going to be 81. So instead of 27, you can say 3 cubed. Quantity raised to the 3x minus 2 power. And instead of 81, you can say 3 to the fourth power. Quantity still raised to the 7th power. Okay, I'm going to give you one more minute. Okay, so 3 to the fifth power is 243, so 3 to the negative fifth power is going to be 1 over 243, which is answer selection D. The fourth root of 625 is asking you what number times itself, or raised to the fourth power, is 625. That's going to be 5, because 5 times 5 is 25. 25 times 5 is 125. 125 times 5 is 625. So that's 5 to the fourth power. So the fourth root of 625 is 5. That's answer selection B. Oop. Sorry, I didn't mean to do that. Deleted the text there. 1.11 is B. And for 1.12, we just need to make sure that you distribute here. So this 3 needs to go to the 3x and the negative 2. And this 4 obviously goes to the 7. So you'd have 3 to the 9x minus 6 power is equal to 3 to the 28th power. Now you have common bases on opposite sides of the equal sign. So you can drop the bases and equate the exponents. So 9x minus 6 is equal to 28. If you add 6 on both sides, then you're going to get 9x is equal to 34. And then dividing by 9, this is not going to be a nice number, but this would be 34 over 9. So that could be a fraction. You're going to see, you have to be comfortable with fractional answers on the SAT. They're going to, on a gridding question, excuse me, you're going to have a grid-in chart that has 4 values in it. And in the middle 2, there'll be a fraction bar a little bubble that has a forward slash in it, and that represents the fraction bar. So you could write this answer, whoops, sorry. You could write this answer as 34 fraction bar 9. If there are any questions, please let me know. Otherwise, let's take a look at this guy. I'm going to give you 2 minutes, and then I'll give you some hints. So for this problem, notice we don't have, we don't have any common bases. We have 16, 4, and 8. We can't use 4 because 4 is not a root of 8. So 8, you can't exponentiate 4 to get 8, but you can use 2 because 2 to the first power is 2, 2 squared is 4, 2 cubed is 8, 2 to the fourth power is 16. So what I would recommend is inserting different exponentiations of the base of 2 in for 16, 4, and 8, and simplifying and then matching against these answer selections. So I'll give you 1 more minute, and then I'll give you the solution. Okay, so instead of 16, I'm going to write 2 to the fourth. So I'm going to have 2 to the fourth quantity raised to the third power, because I still have that exponent of 3 tagging along. And then instead of 4, I'm going to write 2 squared quantity raised to the third power again, because I still have that power of 3, over, instead of 8, I'm going to write 2 to the third and then I have a square on the outside. Now I have powers of powers, so the first value, 2 to the 4th quantity raised to the 3rd, is the same thing as 2 to the 4 times 3 power, which is going to be 2 to the 12th power. 2 to the 2nd power quantity raised to the 3rd power is the same thing as 2 to the 2 times 3 power, which is going to be 2 to the 6th power. And 2 cubed quantity squared is the same thing as 2 to the 3 times 2 power, which is the same thing as 2 to the 6th power. So you can see immediately that the whole value of 2 to the 6th will eliminate in the numerator and the denominator, and so your answer here is going to be 2 to the 12th, which is answer selection A. If you have any questions, please let me know. Otherwise, let's take a look at this problem. This problem is a little bit more involved, and if you have any problems seeing the question, I'm going to try and make it as large as possible, but please just let me know. I'm going to give you 3 minutes for this problem, and then I'm going to give you some hints. Okay, so for this problem, I would recommend that you start with this value over here. So if you look at this guy and you start trying to reduce the variables that occur in the numerator or cancel them out with the variables in the denominator, because overall you have division here because it's a fraction. Excuse me. So we could start by simplifying this really right here, if we thought about this 3w to the third, actually let me get a different color that doesn't show up as well. So I'm looking at 3 to the w to the third power and w to the 8th power here. So that's the same thing as w to the 3 minus 8 power, which is w to the negative 5th power. So we could combine these. If I just left that 6 in the numerator, I'm going to leave that alone for now. The w really only combines to a 5 in the denominator, because the 3 w's, the w to the third power in the numerator, is getting absorbed by the 8 w to the 8th power in the denominator and turning into w to the 5th power in the denominator. Same thing here with the x's. That's really x to the negative 2 minus 8 power. You can do leave, change, change there. So you leave this sign alone, change that one, change that one. That's the same thing as x to the negative 10th power. So that's also going to be in the denominator down here. Oh, excuse me, I'm so sorry. I missed out completely. Let me go back. We have this little teeny exponent right here. So first we need to take care of that. I'm so sorry. I led you down the wrong path. So if we have that little exponent there, we have to make sure that we multiply everything inside the parentheses by that value. So this will turn into 6 to the w to the 6 times w to the 6th power times x to the negative 4th power times y to the 4th power times z to the 8th power, quantity over 18 times w to the 8th, x to the 8th, y to the 8th, z to the 8th. And then this guy is going to stay the same. We have 27 over 9 times w squared, x to the 12th, y to the 4th. So now we can combine, so sorry, and missed that little teeny exponent there. So now we're looking at w to the 6th minus 8th power, so that's going to be w to the squared power in the denominator. Looking at the x's, we have x to the negative 4th minus 8. That's the same thing as x to the negative 4th plus a negative 8 power. That's x to the negative 12th. So we're going to have x to the 12th in the denominator. If we look at, let me get rid of these things right there. If we look at the y's, we have y to the 4th divided by y to the 8th. So y to the 4th minus 8 power is going to be y to the negative 4th power. So we're going to have y to the 4th in the denominator. And notice that the z's cancel directly because we have z to the 8th over z to the 8th. So that's why you don't see a z value in the second fraction. So now we have plus 27 over 9 times w squared, x to the 12th, y to the 4th. So then now they look a little bit more similar. They look more similar to each other. Now what I would suggest is to eliminate, you need to get common denominators here in order to add these values together, right? So in order to get that common denominator, the only thing that they're missing, they share these guys right here. But 18 and 9 are not matching up. So if you divide on the left side, if you eliminate each coefficient by a factor of 2, so if I factored out a 2 here of 6, or if basically I'm dividing on both sides, dividing the coefficient in the numerator and the coefficient in the denominator by 2, I'm reducing by a value of 2. So this would turn into 3 to the 9. So I'm going to give you one more minute. If you go ahead and simplify a little bit more, you notice that you have a factor of 3 in all of these answers. But I'm going to give you one more minute, and then I'll give you the solution. Okay, so in order to add fractions, we need common denominators. We have common denominators now. So we keep the denominator, which is 9 times the quantity y squared x to the 12th y to the 4th, and we add the numerators. That's going to be 3 plus 27. So that is going to be 30 over 9 times w squared x to the 12th y to the 4th. Now we can't match up any of the I should say none of the answer selections match that value, but they're all off by this coefficient of 3. So if I pull a 3 out of here, notice 30 divided by 3 is 10. So instead of writing 30, I can write 3 times 10. I can pull a 3 out of here because this is really just 3, and then that's 3 times w squared x to the 12th y to the 4th. Really should be another parentheses there. But once I pull a 3 out of the numerator and the denominator, the 3's can cancel directly. And so the answer is going to be 10 over 3 times w squared x to the 12th y to the 4th. And that looks like it should have been A, but this guy has a negative sign here. Let me see. This is a typo. Yeah, I apologize. It should have been A with without that negative sign. If that negative were in the numerator, which it could be, they like to write that as that way as well, but let me write this the way that it should have been written. So if this said, notice if that had a numerator of 10 times x to the negative 12th power, you can interpret that as being flipped into the denominator. Okay, but as it was written, I apologize, it should not have been negative 12 in the denominator. It should have been negative 12 in the numerator. Okay, if you have any questions on that, that was a tricky one. We're going to get more practice with these problems. Let's look at this guy. And I'm going to give you 4 minutes for this one. Okay, so let's look at this problem. First of all, if w times x times y times z is not equal to 0, that's a really convoluted way or tricky way of saying that neither w, x, y, nor z could be equal to 0 or can be or allowed to be equal to 0 in the context of this problem. The reason being is that if any one of them were 0, the whole thing would total out to 0, and that's an easy out. They want you to actually calculate this value or simplify as far as you can. So that's why they're eliminating, precluding the opportunity for you to choose any one of the variables to be 0 and just say, hey, the whole thing's equal to 0. Never mind. Also, it would violate a rule. This whole, oops, get a different color here. This whole denominator, if any one of these values were 0, would all multiply out into 0. 0 times any number is 0. You could have a million numbers times each other, and if any one of them were equal to 0, the whole thing zeroes out. And you can't divide by 0, right? It's not allowed in mathematics. You can divide 0 by any number. That just equals 0. So 0 divided by some number is 0, but some number divided by 0 is undefined because division is the separation of values into equal groups. So if you divide it by 3, like if you take 6 cookies and you divide it by 3 into 3 groups, each group gets 2 cookies. But if you take 6 cookies and divide it into 0 groups, that doesn't make sense and you can't do it. So that's why anything divided by 0 is undefined. So this is just a real tricky way of just saying any one of those variables cannot equal 0 by definition. So don't let that confuse you. A lot of students get tripped up on that. Don't let that confuse you at all. You just want to start with your simplification process here. So notice there's nothing really to do with this fraction on the right-hand side. It looks pretty simplified, but there's a lot to do with this fraction right here. So that's where I would start, and make sure that you take a look at those, notice those exponents on the outside of the parentheses. So that needs to multiply those exponents outside of the quantities there need to multiply into all of the values inside of the parentheses. So this is going to turn into 8 times w to the 5 times 3 power times x to the negative 3 times 3 power times y to the negative 2 times 3 power times z to the 6 times 3 power. Quantity over, I should put these in parentheses, 3 times w raised to the 3 times 4 power times x to the negative 2 times 4 power times y to the 2 times 4 power times z to the 4 times 4 power. And then this other guy on the right is just going to follow through for now. So now we can multiply. So this is going to be 8 times w to the 15th, x to the negative 9th, y to the negative 6. I'm just multiplying those exponents out. Z to the 18th, quantity divided by 3 times w to the 12th, x to the negative 8, y to the positive 8, z to the positive 16. Okay, so those are just matching up right here. I'll show you where I got these values. If you have any questions at all, please let me know. And that corresponds with the numerators as well. This guy's just going to follow through again. So w to the 3rd, z squared, all over xy to the 14th. Now deal with the exponents. So we have w to the 15th in the numerator, and we have w to the 12th in the denominator. Division implies subtraction when we have common bases, and which we do here. They're both w. So this is the same thing as w to the 15 minus 12 power, which is w to the third power. So this is going to turn into 8 times the w will remain in the numerator because it's positive. So we're going to have 8 times w to the third. Down here we'll have the 3 still carrying through on the bottom. Now for the x's, the x we're going to have -9 minus -8. X to the -9 minus -8. You can do leave, change here. So you leave that sign, change that sign, and change that sign. That's going to turn into x to the -1 power. Y, we're going to have, now if it's negative, you can either write it as x to the -1 in the numerator, or ultimately what this will turn into is that means that it really gets transferred to the denominator. So I'm going to go ahead and actually just write it in the denominator here. And it has a power of +1 now because I changed it. I flipped it into the denominator. So now it's going to be x to the +1 power. Y is going to be y to the -6 minus 8 power. Again, you can do leave, change. So leave this guy, change that guy, change that guy. That's going to be the same thing as y to the -14th, which I can write in the denominator as y to the +14th. So if it's -14th, if it's y to the -14th in the numerator, its equivalent value would be y to the +14th in the denominator, because remember that rule with negative exponents. Anything raised to the negative exponent is equal to 1 over the positive version of that exponent. And then we have z. Z is going to be z to the 18th minus 16, so that's going to be z squared. Notice now you have common denominators. It just kind of worked out that way. Well, it was written to be that way. So now notice that you have almost have common denominators. You just need to manipulate the right-hand side now. So I'm going to give you 2 more minutes, and then I'll give you the solution. And if you are finished there, you can look at that next problem down below. I think you'll be able to read that. Okay, so we almost have common denominators here. We're just missing a coefficient of 3 on the right-hand side. So if I multiply this whole thing by 3 over 3, notice if I do it to the denominator, I have to do it to the numerator, otherwise I'd be changing the value. Also, you can think about it as 3 divided by 3 is 1, and 1 times anything is that same something, so you're not changing the value by multiplying by some version of 1. So this is going to be 8 times w to the third z squared over 3 times xy to the 14th power minus 3w to the third z squared over 3xy to the 14th. So now we have common denominators. That's that 3xy to the 14th power. So now we can just subtract numerators directly. 8 times w to the third z squared minus 3w cubed z squared. You just subtract away the coefficients because they have the same variables to the same exact degrees. W's to the third, z is squared, so we can just subtract away coefficients. 8 minus 3 is 5. So your answer here is going to be 5w cubed z squared, quantity divided by 3xy to the 14th. And that's answer selection C. If you have any questions, please let me know. Otherwise, let's look at this last problem. This will be the last problem for today's session. I'll give you 2 minutes, and then I'll give you some hints. Remember that A in terms of B, C, and D is just a fancy way of asking you to isolate for A. Everything on the other side with B, C, and D on it or in it will be your answer. So just isolate for A. Okay, so we can see here that we have all different bases. We have 8, 32, 4, and 16. In the learning partner activity that I'm going to post this week, you're going to go through drill sets where you learn your common exponentiations. And so you need to know the explanations of 2, 3, and 4, 5, especially, but you need to know up through squared through your 20s. But here, these are all exponentiations of 2. 2 to the first power is 2. 2 squared is 4. 2 cubed is 8. 2 to the fourth power is 16. 2 to the fifth power is 32. So you can rewrite all of these in terms of a base of 2. So instead of 8, I'm going to write 2 cubed. And that's still raised to the a power. Quantity divided by, instead of 32, I'm going to write 2 to the fifth power. Quantity raised to the b power. And I'm going to say that that's equal, instead of 4, I'm going to write 2 squared, quantity raised to the c, times 2 to the 4th, instead of 16, quantity raised to the d. Now you have powers of powers, so this is going to turn into 2 to the 3a power divided by 2 to the 5b power is equal to 2 to the 2c power times 2 to the 4d power. Now you have common bases raised to exponents, and you're either dividing or multiplying, so you can subtract the exponents or add the exponents respectively. Then you'll have common bases on opposite sides of an equal sign, so you can drop the bases and equate the exponents, and then just get a by itself, and you'll have your answer on the other side of that equation. So I'll give you one more minute, and then I'll give you the solution. Okay, so on the left-hand side, we have common bases and we're dividing. So this is going to turn into 2 to the 3a minus 5b power. And then on the right-hand side, we have common bases and we're multiplying, so we can add the exponents. This will turn into 2 to the 2c plus 4d power. Now we have common bases on opposite sides of an equal sign, so we can drop the bases and equate the exponents. So we can say that 3a minus 5b must be equal to 2c plus 4d. And they ask for a in terms of b, c, and d. So that just means isolate for a, meaning get a by itself. Move this guy down here. So I'm going to add 5b to both sides. So 3a is equal to 2c plus 4d plus 5b. And then I'm going to divide by 3. So a is going to be equal to 2c plus 4d plus 5b, quantity divided by 3. Recognize that addition is commutative, so the order doesn't matter. So it could be any combination like this, right? The numerators can all switch around. It doesn't matter what place any of them are in originally. So those are all the equivalent statements. Also recognize that they could write these as fractions. So this could be like 2/3 times c plus 4/3 times d plus 5/3 times b. Those are exactly the same statements, and which is the same exact thing as 2c over 3 plus 4d over 3 plus 5b over 3. So please make sure that you understand that all of those are the same exact thing, and they could all equivalently be the answer to this problem. Okay, so if you have any questions, please let me know, and you can always comment in the comments below. Please like, favorite, subscribe, and share with your friends and classmates. I'm really trying to get 100 subscribers so I can get my own permanent YouTube channel or live broadcasting things, or broadcasting channel, so we don't have to constantly email out our link every day. But I'm here for you guys every day from 3 till 8:45 p.m. At 5 o'clock, we're going to start the pre-algebra. Then we're going to go into Algebra 1, then Geometry at Algebra 1 at 6 o'clock, Geometry at 7 o'clock, and Algebra 2 at 8 o'clock, each of them running for 45 minutes. Remember that all of these are important skills to have and to brush up on for the SAT, so they're all pertinent and relevant. If you have any questions or I can help at all, please let me know. I'm available on all of my social media. But otherwise, I hope you have a wonderful night, and I will talk to you all tomorrow.